Uh, Hello everyone, thank you for coming here. Sorry for the 2 minutes late. This confirms my lack of estimation capabilities. I had like 45 minutes in advance, but actually the route was closed, so we did need more time to come here. So actually we made it. What? Yeah, but in time. Thank you for coming to this talk. So today we'll be talking about the memory footprint in large Android projects. I'm Osama Hafizas. I'm staff software engineer at Trainline. And for those who don't know Trainline, we basically provide ticket trains across across Europe. It's not about one country, but all countries in Europe. So if you need to book a train from France or from Paris to Berlin or Milan, it's easier to do in an international, I would say, ticket provider. That's it for the advertisement. Now coming to the real talk. So today we will talk about the memory footprint for Android. But why? It's not that, I would say, it's not like composed topics or animations or probably view models or KMM. It's not, I would say, a mainstream topic for now. But from what I see, what I think of is just this is a topic that is framework agnostic. So whatever the technology, whatever the tech stack, whatever the architecture that you are using in your project, you will need this, and I need it also. And the second thing is the perception and the reality of things. The memory topic is very difficult, and it's not that clear, and we have lots of perception around it. So I wanted just to make it clear for myself, for anyone, because I've been in a place where it was not clear for me, like where I need more memory, where it's not, what's consuming memory in my app, in my tools. All the work we have done at Trainline, like in the platform team for the Android developers, all of that was okay. It was clarifying the image about memory, and I can think of that as something like maps. Good thing that we used a map before. We would go back to our maps. So another one. So here, this is the world map. And you can see, I know you're familiar with this map. You know these are the countries. Some countries are bigger than others. But is it true? Let's take an example here. I will use Kenya as an example. It was very hard to find a country that does not have politics included. So Kenya, if I select it here, I don't know why I can't. I will refresh, and of course, I don't have. But then I will need to share my internet again, of course. Live connection. No. Sorry? Yeah, yesterday it didn't work for me. I hope this time work. Okay. Okay, cool. Hope it will work this time. Yes. So this is our country here. Example, Kenya. And if I take an example, Poland. So you can see it here. Can zoom in a bit. Yeah, it will be clear. Yep, like this. The perception is that maybe Kenya and Poland have the same, I would say, surface. But in reality, if we move this up, actually Kenya is bigger than Poland. And you can check the numbers, of course, if you would like. But this is just the result of projection from a spheric world to a plane. But also, this is basically proves that we may have perceptions like these in other, I would say, areas, especially in memory, where you think maybe you have enough memory, but it's not, and vice versa. But this is like a true example of perception vs reality. So if I go back again here, yes. there are a lot of questions regarding memory in Stack Overflow or in the community. I picked this one as an example. So in this one, someone is having a problem with a build, like compile, debug, a Gradle task, and that build is printing an error, out of memory error. Yeah, you can check the link, of course, to see the responses. One of them is this one here, to add more GFM heap to the build, so you can actually unblock it. Another one is about this compiler option to be added in the Kotlin, in the Gradle script. And another proposal is, hey, why not in tests add this, I don't know, arg, and then it will work. As you can see, it seems like people are in different, I would say, paths about that problem. One of the causes is it's not clear where that problem is coming from, and people can't find it clearly. So I think we can find some, yeah, but this is drama of having these problems. Actually, even ChatGPT, if you ask it about this problem, I just copy-paste this from Stack Overflow and ask ChatGPT. The good thing is it mentioned something about big projects and large code bases. And yes, this is a problem that we had in our very large code base Android, and this is something that probably you also have it. Of course, ChatGPT proposed the same solution, but I can assure you it's not the correct solution. So, which brings me to the point that it just feels good also to understand this kind of problems. So without further ado, I will just quit this and run it again to make the color appear. Yes. So these are maybe the tools that we are familiar with. There's the IDE itself. There's build via Gradle, unit tests, because well, of course, I hope we run unit tests. And then we run either UI tests or run the app, and that's coming to the phone. So these are, I would say, the main area that we touch as developers. But actually, I think of it for them as like tools or software running. So the IDE is a software running. Gradle is also a piece of software running. Unit test also, and the app itself. But in our case, in the Android world, these are not only pieces of software, they are just JVM apps. So basically, they are made using Java or Kotlin, but JVM code, and then they are running in the Java virtual machine, all of them. Also, the Android app is just a different virtual machine. We see the Android OS, but it says a JVM app. So this is, I would say, the holistic view that we should have as developers to our ecosystem. And it's crucial, and it will help us along the way. So any JVM app will use, as I said, the Java virtual machine, actually to require it. And each time it will ask for memory space in order to be running. Otherwise, it will not run. In this case, the app says, hey, I need 500 megabytes, and then the JVM will allocate that space in our physical memory on the machine, and then our app goes there and will be running. It's the same case for the IDE, for Gradle, for our tests you will see later, and the app itself. It's always the same. So let's start with Gradle. It's demo time, of course. I spoiled it. So we will see, before this one, I will show you another demo. We will see demo for simple JVM app, and also DocDocGo, which is an open source navigator or web browser. So in this sample here, just remove this. So in this sample, I have on the left side, I have a JVM app, very small, does nothing, very harmful. And I will just make it like this, bigger, okay, clear. And you will see what's the impact of having not enough memory. So in this sample, I have here a table, an array that will be allocating memory, and I will try to allocate it to that table. And then if it will show, hey, a success. Otherwise, it will say, I can't. So we will do it in the old way, the old school, which is compiling the Java class ourselves. So here I will do like this, Java C memory load simulator like this. Click on it. Then that class will be, hey, compiled in class bytecode, of course, the old school way. And then to run it, we can do something like this. And in this example, I'm saying, hey, allocate 256 megabytes, and then try to use 200 megabytes. Try to do that. It should work, of course. Now, there is a way to see how this memory allocation is going, either by IntelliJ or another tool called YourKit. With IntelliJ IDEA, if I open it here, I will say, hey, give me the profiler. It's not the Android profiler. This is the profiler. And by the way, it's only in the paid version of IntelliJ IDEA. So it's not in the Android Studio itself. This is why it's very important to know that. If I go there, I can see here that I have my memory load simulator. Actually, I can try to make it appear better. Presentation mode, yep. Profiler again. Yes, you can see here. Here my JVM app. I can click and say, hey, show me memory live shots. And then here it will appear. And as you can see, like in the heap memory, there is 200 used of 255 megabytes. And this is exactly what we specified in the XMX arg, and then what the app is actually using. Another app that can do this is called YourKit. By the way, I really recommend using this one for when you have really big a need in profiling your apps. Not the Android app, but the ecosystem in general. And you can see here in memory, we have here the memory heap, that one, 1, 2, 3, third one, and it's showing the same number, like 256 megabytes, which is the limit, and what's actually taken. Okay, so this is the case where we have enough memory control. See? Yep. If I try to probably here say, hey, I want to allocate 300 megabytes, but I have only 250, well, then you will have this out-of-memory exception. This is what it's all about. When you have any kind of this error, it means that you have allocated space, a limit, and the actual app usage is way more than that actual limit. Going back to our example of the web browser here, which is DuckDuckGo app. It's a very big app, actually. And I took it as an example so we can see how things are going. So for the same example here, if you can see, they actually have here 4 gigabytes of memory allocated. This is what they allocate to Gradle. If I try to run the Gradle build here, W assemble debug, and I show you here. If I try to go to this one here, you will see here that something appears, and it's called Gradle daemon, and that's actually what's doing the build for us. If I click there, up, can go to memory, and then you can see here that there is like 3.5 gigabytes limit, which is the actual limit of like the 4 gigabytes that we have configured for Gradle in the Gradle properties. So this is like how things are looking. And then you will see Gradle taking more and more space. So Right now it's taking like 2 gigabytes, but the more you build, the more space it will need, and of course it will of course need more space. There is a small detail which is in the upper monitor in there. There is something called garbage collector, which is basically the Java virtual machine providing space to Gradle whenever it's possible. So instead of taking always the space, the 3 or 4 gigabytes that we allocate to Gradle, sometimes it's possible to clean a bit of memory and give it back to Gradle. And this is something that takes time for the JVM. And this tool is great because it will show you how much time that is needed. And actually, it's here on the right side. You see garbage collector time 3 seconds. So in this case, I just ran the debug build, and there were 3 seconds used in the garbage collection. And during those seconds, there's nothing happening in the build. Actually, these are just the JVM trying to clean memory. If I try to limit that and say, hey, you have only 2 gigs, and then I go here and I kill, stop here, up, sorry, and then run the build again. Of course, no build cache. If I go back again, I see my new one here. I will go to memory, and then, as you can see, now we have a new limit, which is like the 2 gigabytes. But I will try to show you also what happened in the garbage collector. As you can see, yep. Let's check the build, if that is finished or not. Yes. Actually, it was taken. It used a little bit of cache there. I will just make a clean build, even better. Thank God I'm on an M1 computer, otherwise it will take a lot of time. Okay, get me there, get in there, get in there, get in there. Up. Awesome. Then I will stop the Gradle daemon and then run again the build. So it will create a new daemon, Gradle daemon, and then that one will redo the build again. Hopefully no build cache is used this time. So if we go to memory, up, we still can see our 2 gigs there. And the garbage collector is working very hard. Should. Yep. During that time, I just want to show you something else. Do you see that Kotlin compile daemon also? Well, actually, when we run the build, there is not only Gradle daemon, there is also Kotlin compile daemon, which is also used in all tasks related to Kotlin, like the annotation processing of Kotlin, also compiling the Kotlin code source. All of that is not done by Gradle. It's actually done on something else called the compile daemon. So actually, when we run the build, there are 2 JVM apps running, and not only one. If I go back again to our sample, just to go to the summary, don't know if the build finished yet or not. Yes, it didn't finish, but you can see like the garbage collector is now at 4 seconds. Now, after you can see it at 6 or maybe 7 seconds. The point is that the less Java heap you give to your JVM apps doing the build, like Gradle or even the Kotlin compiler, the more garbage collection it will be doing, and all of that is waste time for you. And in even bigger projects than this one, the garbage collection can take 20 seconds, 30 seconds, and all of that is taken from your build time. If we are not aware of that, this can scale very, I would say, in a bad way. And also, since we have seen that Kotlin daemon also running here and still running here, there is a way to configure that, which is in the Gradle properties. Actually, we should do it in this code. It's not done, but yeah, it's something like this. For Kotlin daemon, there's possible way to pass an allocated heap space that we would like to have. These values depend always on your project. There is no magic number to say, hey, you have 1 million line of code, so you will need 2 gigabytes of memory. There's no magical, I would say, answer to that. It will depend always to this process. You hit the build without the build cache, and then try to run and see, is it stretching the memory? Is there a lot of garbage collection? If those signals are there and they are blinking red, then you should take care of them and see maybe there is something that we need to do in order to change those limits that we are giving to our tools. Otherwise, we are wasting time, especially in teams doing lots of builds, having 20, 30, 40 Android developers. That will scale very big. Cool. So if I go back here, and I still get the color bug from Keynote. So just a summary of what we have seen. So the Gradle daemon is the GVM app actually doing the build. It depends on your case. In our case, we hit 12 gigabytes to probably now 16 gigabytes. But on large code bases, you will need that space. Of course, the bigger code base, the bigger memory you will need for Gradle, that's for sure. And also, the Kotlin compiler daemon is also another tool doing the build, and it needs memory. And it's very important to think about it and do not forget it on the long run. There was actually, at some point, a bug where Gradle controlled the Kotlin daemon GVM args, but now, hopefully, Gradle team has fixed that. And also, the garbage collection, the more GVM is doing garbage collection during your build, the longer your build will take, and of course, the less happier developers will be. So think twice about that. And the last one that I couldn't do in this example, and it will take even more time, it's the difference between the debug build and release build. The release build will take, by default, even more space, because there is shrinking, there is obfuscation of the code source, and all of that needs even higher, even more space from the memory, and that's very important to test this with the release build. That's very crucial. Otherwise, you will have different behaviors, especially on CI. If you always build the release builds, you will have completely different metrics. So this is also a crucial point. Going back to the next topic, which will be about unit tests. I know maybe it's a lot of information to get for a second day of conference. Feel free to have a pause, 5 seconds pause, or drink water. Yeah, our tools are complicated. So yeah, there is a lot to do. To be honest, I removed a lot of things from the slides, so at least we can see the most important ones. Going to the second one, which is about unit tests. I know that it's the case for most of us, which is having unit tests in our code bases. Actually, in our case, we had a problem with unit tests at some point. So, as many of you have the engineering community pushing to CI, pushing commits, and then CI during running CI checks, the release, the assemble, the test, and so on. And usually they go green unless you have really real failure. Until that changed, and we started having these problems of memory on unit tests. It's not the building of the apps; it's the unit tests themselves. And of course, that causes a lot of friction in terms of developer experience. But mainly, we had like these two main different errors. The first one is out-of-memory exception, like the one we saw earlier. The second one is GVM crash. Like, good luck with that. Like, we had enough from app crashes, and now the GVM crashes itself. That's a thing. Let's go to see the first one. So, in our case, the CI was running this kind of, I would say, task. Actually, it was the release unit test, not the debug one. But yeah, running the unit tests for release. We have the feature modules, like any, I would say, standard Android project. Gradle, of course, see all of those features, and we run the unit tests. This is what it's about, of course. And we know that this is like I would say, like a very old number. We had like 6 gigabytes for Gradle in order to do the build. So if you remember the thing that we saw in the first one, this metric or this XMX arg is only for build. And of course, even by raising this to 8 gigabytes or 10 gigabytes, it will not solve the problem, because that problem is not a build problem, it's in the unit tests. And in order to let you know like how that's working, actually, like Gradle daemon, how it sees the features in our apps, there are like two things. There's the SRC folder, where you have the main folder, when you have the actual code that will be running in the app. And the second one, with the green one you see in the IDE, that's the test sources. And for Gradle, they are two different things. So the first thing that Gradle will do, it will try to assemble the project, so compile the project. And then it will compile the source code of unit tests. And all of that is done by the Gradle daemon, like the one that's doing the build. Interestingly, of course, because all of that is happening in the build, it will be covered by those 6 gigabytes that we have configured. But when it comes to the time running the actual unit tests, Gradle will not use the Gradle daemon. It will use something else called Gradle workers. And those workers, they have the responsibility to run the actual unit tests in our modules. So it's completely different, basically, GVM app that will be running our unit tests. Those Gradle workers are standalone GVM apps, like baby apps of Gradle daemon. And then, of course, it's demo time. I will try to run those unit tests in the code base. I hope it works, of course. Okay, so here we just clean that project. Again, tap. Then try to run the tests, and you will see if there will be actual Gradle workers coming or not. Okay, and then try to run the tests. Yeah, just like this. It will run all the tests, but see. So we will open our favorite app here and see what's coming. You see the new one there? If it showed up and then back again. If we go back, yeah, still there. Okay. Can we see it? So there is the Gradle worker there. If I put it besides this one, yep, it's getting ready. We will see some unit tests running, and on the right side, we will see the Gradle workers working. Getting there. I know why it's taking more time, because I forgot that there was 2 gigabytes instead of 4. Yeah, another reason why it's very important to have the correct number there. Otherwise, build will take even longer. And you can see all those workers there. And if I click on it, like any one of them, please let me. Oh no, we can't. No. Okay, no problem. But the idea is just all of these, they have their own separate Java heap space, and they will use like 250 megabytes by default unless you configure them. But they are, as you have seen, they are different separated JVM apps will do the actual running of unit tests. As you can see on the left side, there is the actual test running, and the right side, all of those are working. Which brings me back to our slide. So I hope now you believe me, of course. So all of those workers are running the unit tests, and of course, now you can see the separation between compile time and build time and actual unit test runtime. It's completely different configuration. And for us, the error was happening on one of those workers for one of those modules. And of course, the 6 gigabytes that we have, it doesn't work for that configuration. There is actually like a different way to configure those, which is in the max heap size property of unit tests. This is oversimplified one because just we configure all unit test modules to take like 700 megabytes. But in real life, you will maybe need to check if a module, like if it's the payment module or the screen that has a lot of unit tests, maybe that screen it will take even more space, and that Gradle module will need more space instead of having like this across the border, which is how we configure that number, magical number for those Gradle workers. And for us, of course, that fixed the problem in one step. But of course, in order to know actually what are the things that get in, you can give memory, all the memory that you need for those, I would say, for any Java app. But in your code, if there is a memory leak, you can give it all the space it will have. It will just crash at some point because it will never be enough. So in our case, we had this 700 megabytes. We did it. We still have the crash, the out of memory. And then, of course, we needed to do the same thing that we have done with Gradle. We picked up one of the Gradle workers and saw how like the memory consumption over time, how that is looking. And you can see from this is that, hey, it's rising. So the memory consumption is always tends to raise, which is a sign of usually of a memory leak. So in that case, there is no actually like, easy solution to these kind of problems. All you need is heaped up inspection, which basically will take an image or screenshot of what's happening in the memory and see it in the table, like where is my memory allocations. In our case, we had luck, just for you so you can take the photo. In our case, we had, I would say, we were lucky, and we saw that, hey, the majority of allocation is going to Mockito, which is a library, and then we figured out, hey, this is probably a problem within the library itself, so it's not even our code like unit test code. So we checked all the release notes, and then yes, they knew that there is a memory leak, and there is this dedicated API in order to clear the mocks. Otherwise, Mockito will keep putting objects in the unit tests, and you will not have enough memory to run. And that was something that we have discovered. And by adding that piece of code, we basically were able from going from the left side to the right side, which is a big difference. And you can see now we can even go back again to like 300 megabytes instead of 700 megabytes because we don't need them anymore. We fixed that leak. So that problem, the out-of-memory exception in unit test was done, but the JVM crash was always happening. And it was a pain in the eyes, I would say. So how that is even possible? So we have this configuration, like the 700 for each module and the 6 gigabytes for Gradle. You can see that how that will lay out in the memory. Those ones, the name is Java heap. That's the name of the allocated memory that we are talking about. There is another thing called non-heap memory, which is something that Java needs in addition to whatever we specify, Java itself, it will need to specify something by itself that it will need to run the actual code that you have for that space. And you don't have control over that. And usually it's 10% of the allocated space that you have configured. Great. So you can imagine, like, in a big app with lots of modules, you run the unit tests, there is a lot of Gradle workers working, and all of them will compete for space. You think that you have enough memory because you made the calculus, but it's not that easy. Maybe you have the Kotlin daemon is sitting there, taking space, and then this is the case where you have a JVM crash. Basically, if you put the, I would say, the sum of all of the allocated space that you have, plus the non-heap space that the JVM needs, and that turns out it's bigger than what the actual memory that you have, it will crash the JVM itself. And that's our case, and that's what we have found. The magical solution of that is manual, unfortunately. For JVM, we needed to basically go and check all our modules and see if we really need 700 megabytes or 300, because the sum of them was bigger than, I would say, what our CI can handle. That process has a name. I was not aware of it. It's called the JVM tuning, and basically it's the process of fine-tuning on adjusting those configurations in your modules, where in your JVM apps, in order to be able to run the actual apps. So yeah, we ended up doing that, hoping for at some point we have dynamic JVM tuning, which come in, I don't know for which version of Java, hoping 33. And yeah, by doing that, we fixed the issue, thankfully. And to summarize regarding unit tests, for each unit test module, Gradle will create workers, as we have seen. Each worker that you have in your code base, it will need its own XMX at some point. By default, there is a basic configuration, but double check, maybe you don't have enough memory, maybe the unit tests are taking more time than they should, just because we have a faulty configuration there. And it was our case for one of the modules, and just by having the right XMX there, we accelerated our unit tests. Non-heap allocated space can take lots of memory, yes, because when you scale lots of modules in a big Android project, of course, if you have like 100 megabytes for each module, just for non-heap, it will add up quickly. And of course, the JVM itself can crash because it cannot handle all the configuration that we have. That's a possibility, but now I hope that you know where that is coming from. And of course, you can go back to this talk and just see how that is laid out. Yep, so that was basically the I would say, the biggest parts of our tools and the most problematic ones. The next two, I would say they are really lightweight, so we can just hover around them. The first one is the IDE. And if you don't know that XMX JVM arg, it's usually right now in the Toolbox app of JetBrains. Like, the Toolbox is the new app that controls the install of IDEs. So you can have it there in that app. You can change the configuration of how much memory do you need. And the rule of thumb here is that if your Gradle builds need 6 or 8 gigabytes, that's clear signal that your IDE will need even more than that, because the IDE will try to duplicate the model of Gradle, of the code base, plus all the nice features that it has and all the modeling that it should do in order to give you like the completion stuff and the other stuff. And it will be even more with local LLMs running inside IntelliJ IDEA. It will need even more time, more space. So rule of thumb, this one is always more than the Gradle JVM args. And another one is a feature that IntelliJ has is shared indexes. It's very good in order to reduce the memory footprint. Actually, it's the same for Gradle. So Gradle, if you use build cache, you will consume less memory. The same applies for the IDE. They have this feature. It's called the shared indexes. So you can optimize that, and you could have less memory footprint of the IDE. And another crucial one, which it's easy to miss, is having both Gradle running from IntelliJ IDEA and the one that we run from the command line. If you run a task from IntelliJ IDEA, it will create new Gradle daemon. If you create one from the command line, it will create another one. And imagine if you have Gradle daemon with 12 gigabytes of memory, you will have 2, and that's 24. So when trying to do command line or IDE, it's very crucial to make to see this coming. Otherwise, you will have the JVM crash very easily. And the last point, or last thing, is for your UI tests. Probably you are running UI tests. There is the equivalent of that JVM arc for the emulator, which is this one here. It's really hidden in the configurations. So you have the RAM, which is the memory, general memory for the emulator. But you have the VM heap, which is the actual heap size that will be allocated to your app when it's running on the emulator. For us developers, it's good to have control over that. In production, we don't have control because that's hard-coded in the phones of people. But this might be crucial if you are using UI tests and you have lots of UI tests to run. This can be very, very useful to have or to add. And of course, you're probably familiar with Leak Canary. I really encourage you to use it just to know what are the memory leaks in your app. That was very crucial. Jumping to the end of all of this, I would say, a drama film about memory. Like, to have the holistic view, if you have Gradle taking 12 gigabytes at some point, and the Gradle and Kotlin 4, and the unit test taking 2 gigabytes, plus the IDE, plus the emulator, you will end up easily having 30 gigabytes of required memory just for basic tooling. I'm not talking about whatever browser you are using or other tools you are using. That will hit developer experience very hard. So probably one takeaway from this is why not by default have 64 gigabytes when you have lots of big, large code bases. Otherwise, cloud IDEs are coming and they are getting mature to be a thing where we can basically run the app and all this tooling will be on servers. But until then, make sure to have these numbers correctly. And that's it for this talk. Thank you so much.